All right, good morning, and thank you for joining us today for our webinar. My name is Scott Johnson. I'm the Global Business Manager for Advancion Paints and Coatings. Today, we're really excited to share with you our latest applications work that highlights the unique performance and functionality of our multifunctional amino alcohols, specifically in regard to helping optimize the dispersion of TiO2, organic pigments, and anti-corrosion pigments. Our goal today is to also provide you with the opportunity to ask technical questions of our dedicated coatings application team so that you gain a better understanding of how Advancion ingredients can improve the performance of your paints and coatings formulations. If you have a question during the webinar, please feel free to use the Q&A function in the WebEx application, which is available on the right side of your screen. We will collect your questions throughout the webinar, and at the end, we will cover Q&A after the presentation. So in closing, we appreciate your ongoing interest and engagement with Advancion, and we'll now turn the webinar over to today's host and our customer application specialist for the Europe, Middle East, and Africa coatings market, Dr. Sadan Rezagia. Sadan?
Yes, good morning, everybody. The topic of today, the title is written in the slide here. We are going to talk about this multifunctionality of our additives and how we can maximize the use of these additives in optimizing the pigment dispersion and optimizing the paint performance. Basically, the main topic here will cover, this important qualities that we need to reach with paints. I can list some of them: hiding power, color, and formulation optimization. This is the outline of the presentation. We will go through introduction of the company Advancion, and then we will talk about titanium dioxide dispersion. We move again in the third topic, anti-corrosive pigments. And then we finish with organic pigment dispersion and how we can prepare pigment pastes. We are an American company, Advancion. We are supplier of additives and ingredients for multiple applications in markets. And yes, and we have an extensive record in innovation and technical application development. We have two production sites. One is in US and the second one is in Germany. We are ensuring a global supply through these two production sites. We have 6 R&D centers located in the Americas, Europe, and Asia. And we have also a strong focus in supporting our customers, local customers and worldwide international customers with regulatory concerns. Our product portfolio, you can see it in here. In the left-hand side, we'll talk about these amino alcohols and their multifunctionality in preparing pigment dispersion and paints. And this will be the principal presentation here. And we have one product called carbodiamide, which is a carbodiamide used principally for cross-linking at room temperature or high temperature water-based dispersions like PUDs, acrylic, or even alkyds. And this product is used for wood, adhesives, leather, plastics, metal as well. And it can improve a lot in terms of abrasion resistance, chemical resistance, abrasion resistance, chemical resistance, blocking, and salt spray in humid conditions. In the right-hand side, we have a variety of solvents that we use in solvent-based media. These solvents are used as co-solvents. We are not claiming to use our customers to use these solvents as principal solvents, but we claim also to use them as small additives, small proportion of our additives. And we have some specialty surfactants based on oxazolidine chemistry. And these kind of surfactants are widely used, let's say, in pigment grinding, dispersion in mineral oils or resin, solvent-based resins. We have one product, Zoldyne MS Plus, which is a mouse scavenger. This product is not REACH classified, is only available for US and Asia, and not for Europe. As you can see here in this slide, we are sorry. As you can see here in this slide, you see the structure of the amino alcohols. All of these structures you see in this slide, they mention that you have products containing some functional groups, OH functional groups, and amine, tertiary or primary amines. And when you take a look to the central carbon in these four products, except the MOPA, the one in the bottom side, bottom right-hand side, all of these four products, they have central carbon which do not have any abstractable hydrogen. So there is no hydrogen adjacent to this tertiary carbon. This means that in terms of UV resistant, these products are very stable. They will not promote any yellowing or degradation. And at the same time, there is no way to get a thermal oxidation. There is no way to get a peroxy radical or something like that. This kind of products, all of them, they cover different pKa's from 8.8 to 9.4. They cover, the pKa's needed for water-based systems. And in addition to these products, they exist, all of them, in anhydrous forms. Anhydrous forms, this means that there is no water inside, or at least small quantity of water inside. And if you take a look to this chemistry, you see that the functionality of these, when they are considered as anhydrous, they have, functionality of one, functionality of zero, like the MOPA, functionality of one, like DMANP, functionality of 3, and functionality 4, and functionality of 5 of trisamino. Keeping in mind that the functionality of amine is bifunctional. If you take an amine, primary amine with 2 functionalities, and you add the functionality of the 3 hydroxides, you have a functionality of 5. And this gives a picture of these people trying to use these anhydrous forms in reactive systems to be considered in their formulation. Let's move to this functionality in water-based liquid systems. As you see here in the left-hand side, you see that our amino alcohols, they absorb on the pigment. They absorb on the pigment. This is what we entitle pigment dispersion. They have a high absorption on pigments. And when they absorb on pigments at a certain level, when they exceed the amount which allows for encapsulation or, let's say, absorption on the pigment, the remaining amino alcohols will be a counter-ion of this dispersing agent. A counter-ion on dispersing agent. This means that it will enable a good paint stability. In terms of stability, sedimentation will be avoided, and in terms of pH. And in terms of pH, this will be ensured through the neutralization effect. When you have a good neutralization, you are making your dispersant agent good stabilizer and avoid to have any pH stability evolution. In the right-hand side, we have some other benefits. Amino alcohols, at least 2 of them, they are quite used in improving the synergetic, the preservation with the biocides. The preservation time when you are using ANP, the in-can preservation of the water-based systems is extended with ANP and AEPD. The other attribute here is anti-corrosion. Anti-corrosion, when you are deflocculating or disaggregating the pigments in a correct way, bringing them to the primary particle size, distributing them in the matrix, in the binder matrix. Somehow you are improving the dispersion of the anti-corrosive pigments, and this will enable to have a benefit in anti-corrosion performance. And the last thing is that one of our products, Trisamino brings a formaldehyde scavenging. In interior air quality, when you are making a paint, having formaldehyde, having Trisamino in your paint will capture formaldehyde in the interior space, and this will benefit in improving the interior air quality of your spaces. It can be rooms, it can be schools, it can be hospitals. Let's come here to titanium dioxide. For titanium dioxide, you see here a plot showing, let me take this out, a plot showing the dispersion of titanium dioxide at a low concentration. You see the black curve is showing the percentage of amino alcohols free in solution, and the red curve is showing the adsorption on the pigment. You see, when you are starting to have very low amounts of amino alcohols in the titanium dioxide slurry, you absorb immediately, and then the curve will move when you are increasing the proportion of amino alcohols. This means that adsorption is very important at very low concentration. And when you reach a certain level where the adsorption is optimal, amino alcohols will be used for additional features like improving pH stability or improving the grinding during the grinding process. Here in order to illustrate this, we did a design of experiment with plenty of slurries prepared, 140 here, and you have the inputs. Within these inputs, what you see is that we are varying the amino alcohols, we are varying the nature of titanium dioxide, we are making the adsorption curves, and we are also measuring the output of these paints or slurries. We measure on them the dry opacity, the adsorption, and also the particle size. And if you take a look to what we have plotted here, here we are plotting the dry opacity with the dry opacity versus the additives, you know, the different types of amino alcohols. We see here that with using amino alcohols, we have a robust evolution of the dry opacity. We don't have a high distribution of the data compared to when we are using sodium hydroxide. This means that opacity is controlled, and you see that DMANP and ANP, we have a high dry opacity average with them compared to sodium hydroxide. This curve shows the what we call titanium dioxide co-dispersion. We are here doing a slurry with titanium dioxide, and we are dosing the percent of dispersant, and we are grinding at the same time. And what we see is that when you are using sodium hydroxide, you need to put a lot of dispersant agent, orotan 371, whereas when you put small amounts, 0.05 weight% based on the titanium dioxide, your proportion of this dispersant can be reduced significantly. This means that you are optimizing the use of dispersant, and you can also claim that you are avoiding to have too much hydrophilic components coming from the orotan, which is carboxylic high molecular weight carboxylic, and you are improving the hydrophobicity of your slurry. And you can imagine that this can work also for paints. And for paints, you can also optimize the proportion of this dispersant as you do it here in the slurry. So whatever the titanium oxide is not negatively affecting the absorption of amino alcohols. What we've done here is a measurement to illustrate how amino alcohols can improve the dispersion efficiency. We took our disperser, we monitor the power of the engine. We proportionate, let's say, the viscosity of the medium with the size of the helix and the velocity we want to input on the medium, and we find a way to calculate the energy consumption. And we did that with the same formulation, eggshell formulation, PVC 35. We keep the same amino alcohols, ANP 95, same speed of shearing, speed of grinding. And we did this 4 times. When you take a look to the results here, we show here that all of the amino alcohols tested here, ANP, AEPD, and DMANP, they improve the dispersancy efficiency. In this way, we are achieving effective dispersancy, and we are also reducing the dispersion time. I mean, if we don't want to reach a certain level of dispersion, you can do it in a shorter time. And this, of course, will reduce the energy consumption, which will be a large benefit if you calculate this on a large time scale, 1 year or 6 months or something like that. For the anti-corrosive pigment dispersion, which is very important for DTM or DTM formulations, we know the benefits of these amino alcohols, and we will share it with you here. In water-based DTM or metal coatings with anti-corrosive pigments, we're looking for to improve, the pH, the color stability, like water-based decorative coatings. We want to improve the opacity, the gloss, the wet adhesion, the corrosion resistance. And we want also, based on the concept of high absorption of our amino alcohols on the pigments, including anti-corrosive pigments, you can see in the slides which will come that we have the possibility to reduce the anti-corrosive pigments to a level up to 50% weight in the recipe. 50% weight based on what we are using in the proportion of anti-corrosive pigments. And we have also the possibility to reduce the dispersant, surfactant, and flash thrust inhibitor up, let's say, to between 30 and 50%. These are, let's say, the conclusion that even with DTM coating, amino alcohols, ANP, DANP have excellent potential for improving the performance of anti-corrosive paints. We have been selecting to do the work different anti-corrosive pigments from the marketplace, traditional zinc-based anti-corrosive pigments, and new generations which coming slowly on the marketplace, calcium-based. And what we see here in the determination of the particle size when we are doing the slurries based on all of these 4 anti-corrosive pigments, we see that the particle size is highly reduced when we are using our alkanolamides. We have outstanding wetting, dispersing effects on the anti-corrosive pigments compared to ammonia. With ammonia, you reach something like 5 microns, 5.5 microns, whereas with all of these amino alcohols, we can reach a level of 1 micron and even below 1 micron, which is very good for the anti-corrosive performance in your paint, because your pigments are going to be homogenized in the polymer matrix, in the binder, in the fillers, and this will make, the anti-corrosion performance going better. Same way, we did also the hiding power compared to ammonia here. You see that with all the amino alcohols, the hiding power is improved. Especially with the ANP and DMANP, but DMOPA and AEPD are also better compared to ammonia. Coming to salt spray, using amino alcohols on anti-corrosive pigments, we discovered that we can reduce the proportion of anti-corrosive pigments. Here is the example using the zinc-based coatings, the ZP. You see that if you want to make it with ammonia in the left-hand side, you need to have a high proportion of zinc anti-corrosive pigments. And if you do it with any of our amino alcohols, ANP, DMANP, or DMOPA, you can lower the proportion of these anti-corrosive pigments by half. From 8%, you can make it with 4%, and you achieve the same performance of anti-corrosive pigments. And this is a good improvement at equivalent corrosion resistance compared to ammonia. The protocol is mentioned here. The same way, if we suggest to our customers to look also for the reduction of the surfactant. The high absorption capabilities of our amino alcohols on the anti-corrosive pigments can help you reduce the proportion of the primary dispersant. For organic pigment dispersion, here is a plot showing the absorption. We are doing the absorption on different organic pigments, on different 2 carbon blacks and 1 titanium, which is TNP-free. And you see that all of them have a very good absorption on all of these pigments. Organic pigments, we have 5 organic pigments here. We have 2 blacks, we have titanium dioxide. And DMOPA, our new product DMOPA, is showing a better performance and excellent absorption compared to others, but DMANP and ANP are also performing quite well. These are the types of organic pigments we have been covering, from the red to yellow, then green, the blue, the pink, and the pink one, the last one. You see the structures of these organic pigments are quite different from titanium dioxide. They are quite hydrophobic. We have discovered that in terms of absorption, our amino alcohols absorb on this. And this result shows to you the evolution of the tinting strength difference between systems used with sodium hydroxide and ammonia. When we are adding these pigments in the white paints at a proportion of 3.6% in the white paints, and we show that the baseline is 0. This means that all the values above the 0 are showing an improvement in tinting strength, and all of them below the 0 are showing very, bad, or let's say less tinting strength. In overall, all the ANP here, ANP 95, is showing a very good improvement in the tinting strength when we tint our white paints, where we have been using 9 commercial paints. And with all of them, ANP is showing an improvement in the tinting strength. On average, MMP leads to an improvement of the color strength by a range, let's say a value of at least 2.5%. And this is even, we find it even with a hard pigment, the red one, which is quite difficult to absorb amino alcohols on it. Even with the red, the results are good. With this plot, what we are showing here is the illustration of the color strength, how color strength is improved compared to a system using sodium hydroxide. You see the pictures here of the cards, you know. Whatever the proportion of the pigment in the white paints, the pigment when it is added in the white paints, we are boosting the tinting strength compared to sodium hydroxide or ammonia. And that's why we can claim here that amino alcohols will help you improving, you know, the proportion of the pigment used in the white paints, and also optimize the cost of your paint colored with pigment pastes. Sorry. In this case, in this slide, you have a slurry of organic pigments in water with a proportion of amino alcohols, and we keep the percent of the organic paint at 20%, and we measure the percent amino alcohols absorbed as a function of the type of amino alcohols. And you see here that we have a high variability depending on the organic pigments. Absorption depends on the nature of the amino alcohols. That's why we recommend for our customers to come to us if there is a specific formulation with a specific pigments, and we can suggest you the right amino alcohols which could be used suitably. I mean, suitably with preparing the pigment paste, or even when coloring the paint. Here, what we show at this slide is that ANP in the formulation that we have chosen is replacing 50% of the dispersing agent. Dispersing agent here is a mixture of anionic and non-ionic dispersion from Clariant, former Clariant. And when we are reducing this proportion of 50%, we are somehow improving the hydrophobicity or reducing the hydrophilicity of our pigment paste. And we are at the same time increasing the solid content. We are increasing the solid content at an equivalent viscosity. This means that we are not changing the viscosity of the paste, which is the right viscosity suitable for the tinting machines. We are working at the equivalent viscosity, and we discover that we are increasing the solid content, and we are also having a better tinting strength. In overall, what I can see here is that if we use amino alcohols, like you see it here, we are in a way, or any neutralizer, any amino alcohols in our series, you can have a lot of benefits. If you don't use them, you can lose a lot of benefits as well. So if you don't use them, you miss in providing a better pigment dispersion. You miss also increasing the opacity, the hiding power. You miss also the opportunity to optimize your formulation, getting it correctly done, highly hydrophobic, not too much sensibility to water. When you optimize the proportion of the dispersant and the surfactant. And you miss also the possibility to optimize the concentration or the level of anti-corrosive pigments, while achieving the same corrosion resistance. So you miss all of these, and compared to amino alcohol, compared to amines, I mean, which are used at neutralizer, we are above, significantly above the performance of traditional amines and blends of amines, because we are giving a multifunctionality that can help in playing with the formulation, optimizing it, getting a better hiding power, getting a good control on the formulation, and getting also a good control on the tinting strength of organic pigments, and also a good control of the corrosion resistance. So for organic pigments, I would say that in overall, we have a better adsorption, and the adsorption, as we saw it before, it's a function of the color index. But in any way, the tinting strength is increased systematically when we are using our amino alcohol. And increasing the solid content of our pigment paste is always ensured, even with difficult pigments like the red one, the PR254. Of course, at the same suitable viscosity, which, as I said, is suitable for the tinting machines. And that's the end of my talk. So please feel free to ask any questions. We'll be happy to answer. Do you hear me?
Yep, thank you, Sadan. There is no questions at this time. As a reminder, if you have a question, you can use the Q&A function on the right side of the WebEx, or also use the chat function. We will answer your questions.
In case you have more additional questions, please, you can have the contact of our commercial manager, or you can, if it is technical, you can send it to me, and I can provide the information. Or any sample request.
Saddam, looks like no questions at this time. I have one question that comes in. Do you know if AMP or other Advancion ingredients are working with the new surface treatment of TiO2?
We did a lot of work on titanium dioxide, all generation of titanium dioxide, and we've done also a trial with one of the titanium dioxide, which is TMP3. The one which is mentioned is in one of the slides here, TM3741, which is TMP3. We know that the situation will change, and titanium dioxide suppliers are working on some other derivatives of titanium dioxide. TNP3, it seems that TNP3 is also a concern today. We are following that, and we plan in the future to cover this new titanium dioxide modifications.
We have another question that comes in. I believe this says, do Advancion ingredients help improve the storage stability of 70% TiO2 water-based slurry used for wood coatings?
For storage stability, we have been showing in other presentation, doing the traditional test, the tropical test at 48 degrees for a couple of weeks, 4 weeks. We have been proven that the storage stability is improved compared to ammonia or sodium hydroxide, especially ammonia, which is quite, will evaporate and will change in the pH. So pH stability and storage stability, room temperature or high temperature, tropical test, we are improving with amino alcohols. AMP.
All right, we have no further questions. So following this webinar today, we will send an email to all of the participants with a link to a video recording of the webinar. It will be password protected, but please feel free to share that with your other colleagues. And we really appreciate you joining us today. Appreciate your business, and we'll continue to offer new insights as we look ahead to 2025, and we'll be doing some additional application work with our materials, and also looking forward to introducing some new materials as well to the market in the new year. So thank you for joining us today. Thank you, Sadan, for the great presentation.
Thank you.
We wish you all well. Thank you very much.
Thank you. Bye-bye.